Hello students, good morning. Today we are going to see the continuation for the lesson 9, that is the solution topic. The previous video we have studied about the qualitative properties. What are qualitative properties? The study about this elevation of boiling point, depression of freezing point, and also the osmotic pressure and the osmosis and osmotic pressure, and also the vapor pressure. So the study of this all these properties, that is called as qualitative properties. So in this qualitative properties, the remaining one topic is there. So that is osmosis and osmotic pressure. Before going to that, what is meant by depression in the freezing point? What is meant by depression of freezing point? What is meant by freezing point? The substance which the boiling of the freezing point is defined as the temperature at which the solid and the liquid state of the substance have the same vapor pressure. That is called as freezing point. So here, how to calculate the depression in the freezing point? So first we are taking the known weight of the solute. So that is the solute, the non-volatile solute is added to water at its freezing point is calculated. That is called as below the freezing point below 0 degrees Celsius. So that is from the solute. Say for example, so the depression of freezing point can be calculated delta TF. Okay, so first a known weight of the solvent, pure solvent, the freezing point can be calculated as, that is TF. So this is the pure solvent. Okay, that is the pure solvent. The temperature can be the freezing temperature can be calculated pure solvent, that is TF. Now we are adding the solute. So that is the pure solvent, that is TF0. That is solute we are added in the solvent. After then the temperature can be calculated. The temperature is called as TF. So that is the difference between the pure solvent, that is delta TF. How to calculate delta TF? The difference between the pure solvent, freezing point of the pure solvent, and the solute. So the temperature, the difference is called as depression of the freezing point. So that is, hence how it can be calculated, that is the delta TF is directly proportional to the molality of the solution. Delta TF, that is M. What is M? That is M is the molality of the solution. Now we are introducing the constant, that is delta TF is equal to K, that is the freezing constant, that is M, right? Now again, what is M? M is equal to molality of the solution. Molality of the solution. Molality of the solution. Then again, what is mean by Kf? What is the Kf? That is the freezing point constant or the cryoscopic constant. Cryoscopic constant. Freezing constant or the cryoscopic constant. Okay. Now, so when M is equal to 1, then delta Tf is equal to Tf. Okay. Now we have how to calculate the molar mass of this depression in the freezing point. How to calculate? That is, we are taking the known weight of this W gram of solute. Known weight of W gram of solute and the W A gram of solvent. Okay. This is the weight of this solvent and the solute. What is mean by M? What is mean by molality? We already studied. What is molality? Number of moles of solute. Number of moles of solute into 1000 divided by weight of the solvent in gram. Weight of solvent in gram per solvent in gram. Okay, so now how to calculate? That is, now the number of moles of solute. That is, what is number of moles of solute? N is equal to, how to calculate N? Number of moles of solute, that is WB divided by MB. That is molar mass of the solute. So that is what is MB, that is the molar mass of the solute. Okay. So what is MB? That is the molar mass of the solute. Therefore, M is equal to WB by MB into 1000 divided by, that is the weight in the solvent in gram. So that is called as WA. That is known weight of this WA. Okay, so now this is now we are introducing the constant. This is M. What is delta TF? Delta TF is equal to KF into WB by MB into 1000 divided by WA. So molar mass of the can be calculated using this. So how to calculate? What is MB? So from this MB we want to calculate, mean how to write? MB equal to, so KF by delta TF, right? So then WB divided by WA into 1000. Okay. So this is the molecular weight calculation of this given compound, the depression of freezing point. Using this calculation we can easily calculate the depression of freezing point. Next we are going to see the what is meant by osmosis. Okay, next one is what is meant by osmosis. What is osmosis? So that is the many biological process in our body. So most of the biological process takes place in the principle of osmosis. Okay, it is a spontaneous process. That is solvent molecule is passed through the semi-permeable membrane. So that is the solvent molecule is passed through the semi-permeable membrane, right? Semi-permeable membrane. So from the solution, from a solution of lower concentration to the higher concentration. Lower concentration, the solvent flow from the lower concentration to the higher concentration. Higher concentration, that is called as osmosis. The osmosis is derived from osmo, that is mean by the Greek word that is osmos, which is mean by, that is there is a Greek word. What is the meaning of osmos? That is to push. To push. So it is also important to know the semi-permeable membrane, how to calculate the how to osmosis takes place. So that is, this is one diagram. So here that is osmosis and osmotic pressure. So here this is one diagram, right? So this is the, so this membrane is a semi-permeable membrane. So this is the, so here what is this? This is the pure solvent. So this is the solution. What is meant by solution? So that is lower concentration. Solvent only lower concentration. This is the higher concentration. The solvent move from the lower concentration to the higher concentration through the semi-permeable membrane. That is called as osmosis. What is meant by osmosis? The solvent flow from the lower concentration to the higher concentration through semi-permeable membrane. That is called as osmosis. Okay, so now how it will stop the, how to calculate the osmotic pressure? When a small amount of pressure will apply on this using this piston, the small amount of pressure to stop the flow of solvent from the lower concentration to the higher concentration. That pressure is called as osmotic pressure. So what is osmosis? Osmosis அப்படினா lower concentration ல இருந்து higher concentration க்கு solvent ஒரு சைடுல இருந்து இன்னொரு சைடு ஒரு semi permeable membrane மூலமா மூவ் ஆகி போறதுக்கு பேரு தான் என்னது osmosis. இப்போ what is meant by osmotic pressure? So அந்த flow and the flow continuously நடந்துட்டே இருக்கும். அந்த flow stop பண்றதுக்கு we are applying some external force, pressure. That pressure is called as osmotic pressure. Okay, that is called as the osmotic pressure can be applied, mentioned, that is pi. Okay, the osmotic pressure can be calculated, that is pi, that is called as osmotic pressure. The pressure must be applied to this solution. What is meant by osmotic pressure? That is the pi. Okay, this is pi. Pi is, that is called as osmotic pressure. The pressure that must be applied to the solution to stop the solvent through the semi-permeable membranes, to stop the flow of solvent. Okay, that is called as osmotic pressure. Okay, once again, what is meant by osmotic pressure? The pressure must be applied to solution to stop the influx of the solvent through the semi-permeable membrane. So, எந்த ஒரு pressure வந்து அந்த flow of solvent வந்து stop பண்ணுதோ, that pressure is called as osmotic pressure. Okay, so this is called as osmosis and osmotic pressure. So, that is the dilute solution of the osmotic pressure is directly proportional to the molar concentration of the temperature. So, that is pi is directly proportional to the molar concentration of the temperature. So that is we are introducing the constant, that is C, that is concentration, that is CRT. C concentration of the solution, molarity, temperature, or what is R is the gas constant. Using this equation, how to calculate the determination of this molar mass of the osmotic pressure? According to the Van Hoff law, What is Van Hoff equation? Van Hoff equation. What is Van Hoff equation? That is pi is equal to CRT. Pi is equal to CRT. Okay. What is concentration? C is equal to number of moles per volume. What is C? C is equal to concentration. What is concentration? Number of moles per volume. That is N by V. Now you substitute that N by V R into T. Okay. So now pi V is equal to nRT. Okay. This is one equation. It is the solution is prepared by, that is the non-volatile solute. That is WB gram of solute and WA gram of solvent. Okay. Solvent. So N is equal to, what is N? WB by MB. What is MB? Molar mass of the solute. So what is pi? Pi is equal to N by V. So that is WP. That is here, now you substitute this one. Pi is equal to, this is first equation, this is second equation. Substitute 2 in 1. Okay. So now you substitute this one. Pi is equal to WP. What is N? WP by MB into V. So the V this side vanduchu. So that is V RT by, so this is RT. Okay, now what are the thing you are cancelled? So that is WB by MB into RT by V. Okay, so this is the pi. We want only the molecular weight of this unknown solute, right? So pi is equal to WP by pi into RT by V. Okay. So this is the RT pi into V. So this is the molecular weight of this solution using the osmotic pressure. Okay. So what is the significance of this colligative osmotic pressure? Okay, so what is the significance from among all the colligative properties? So what are the colligative properties? So that is elevation of boiling point, and depression of freezing point, elevation of boiling point and depression of freezing point. From the, when comparing all these things, the magnitude of osmotic pressure is very high. Magnitude of osmotic pressure is very high. Okay, so that is the reason we are using that one. So the osmotic pressure can be calculated even at the room temperature. So that is the second point. First one. What is the second point? You can easily calculate it even at room temperature. Okay, so when compared to other thing, it can be easily calculated even at room temperature. So second one. Third one, even very dilute solution, osmotic pressure is also large. Even very dilute solution, the osmotic pressure is large. Okay, so this is the another thing. Osmotic pressure is large, very dilute solution. Okay, so these are the significance of this osmotic pressure. Next we are going to see the what is mean by isotonic solution. What is isotonic solution? Isotonic solution. What is isotonic solution? Two iso means same. So that is tonic solution. Two solution having the same osmotic pressure at a given temperature. So this is very important question. So what is mean by isotonic solution? Two solutions having same osmotic pressure at given temperature. Temperature is called as isotonic solution. This is very important. Here the two solutions having the same osmotic pressure at a given temperature. The word is very important, as at a given temperature. That is called as isotonic solution. So here that is the either in the same direction, that is such solution is separated by a semi-permeable membrane, solvent flow between one to other either direction or same. The net solvent flow between the isotonic solution will be same because both the sides are the same pressure. So that is the isotonic solution means the net charge will be the flow will between the two isotonic solution. Net solvent flow between the two isotonic solution will be 0. Okay, so the osmotic pressure of the blood cells is approximately 7 atmosphere at 37 degrees Celsius. Even blood pressure, osmotic pressure of the blood, osmotic pressure of blood, that is 7 atmospheric pressure at 37 degrees Celsius. Okay, so here the intravenous injection, the same osmotic pressure that of the blood, isotonic, with this intravenous solution too dilute, that is hypotonic. Suppose intravenous inside the blood vessels, the solutions are the dilute mean, that is hypotonic. The solvent flow outside the cell will flow into the cell. So what is osmosis in our body, how it takes place in the blood cells? So that is the dilute solution, the solvent flow, the blood flow from the dilute through the hypotonic, the solvent from the outside of the cells will flow into the cell normalized. So that is called as hemolysis. What is meant by hemolysis? So osmotic pressure and the process which is called the hemolysis, the cells to burst. So what is meant by hemolysis? What is hemolysis? Hemolysis. So what is hemolysis? When you burst of the blood cells. What is mean by burst of blood cells? So if I say for example, so in a small cut in your finger, so immediately after some time, within few seconds, 1 or 2 seconds, the blood will be clotted. What is the mechanism takes place? So that is in that place the hemodialysis will be takes place. So here that is the blood cells containing the platelets. The platelet cells are burst and they release some enzymes. So in that the coagulation will be occur on that particular places. So that is called as hemolysis or the coagulation. So the intravenous fluid. So here that is the same thing. So here the molecules will flow out of the cells. So that on the other hand, the solution is too concentrated, that is hypertonic, the solvent molecule will flow out of the cell which causes cells to shrink. இப்போ என்ன அப்படின்னு சொன்னா, இப்போ உங்களுக்கு blood cells இருக்கு இல்லையா, blood cells இப்படி எடுக்கும்போது ஸோ 2 cells இருக்கு. இப்போ உள்ள ஹைப்போவா இருந்துச்சு. வாட் இஸ் மீன் பை ஹைப்போட்டோனிக்? Hypotonic, the intravenous solutions are too dilute. So appo romba dilute irundha, that is hypotonic. The solvent from outside of the solutions will flow into the cell to normalize the hypotonic osmotic pressure. இப்போ இங்க dilute இருந்தா இங்க outside ல இருந்து solvent flow inside. இது blood cells னு வெச்சுக்கலாம். blood cells. So solvent என்ன ஆகும், உள்ள இதை neutralize பண்ணும். Suppose in case, so if the solution is too concentrated, the same so that is called a hypertonic. Hypertonic means that is highly concentrated. என்ன நடக்கும், the solvent molecule will flow out of the cells. இப்போ இங்கே இருந்து அது வெளியில வந்துடும். So வெளியில வந்தோடனே the cells become shrink and become to die. So for this reason the intravenous fluids are prepared such they are isotonic to blood. So that is the sodium chloride solution. So that is the IV line சொல்றோம் இல்லையா, IV line எப்பவுமே உங்களுக்கு isotonic அந்த bloodோட isotonic லெவல்லே IV line prepare பண்ணிருப்பாங்க. What is the IV intravenous line? அந்த solution என்ன 0.9% mass per volume of sodium chloride solution. Okay, so this is the IV fluid. What is IV fluid? Intravenous fluid. Okay, so this is the another one. So next we are going to see the, so இப்போ hemolysis அப்படின்னா, so இப்போ ஒரு இடத்துல burst ஆயிடுச்சு, ஒரு இடத்துல கட் ஆயிடுச்சு அப்படின்னா அந்த இடத்துல coagulation நடக்கும். So இந்த இடத்துல ரெண்டு solution இருக்கு. Hypotonic means that is too dilute. Hypo means கம்மியாக இருக்குதுன்னு அர்த்தம். ஹைப்பர் ஆக்டிவ்னு சொல்கிறோம் இல்லையா, அப்போ highly concentrated, ஞாபகம் வச்சுக்கோ, ஹைப்பர் ஆக்டிவ். ஸோ ஹைப்பர், that is hyper means highly concentration, hypo means low concentration. ஸோ low concentration means solvent வந்து வெளியிலேருந்து உள்ளே வரும். ஸோ அது ஆஸ்மாட்டிக் ப்ரெஷர் பேலன்ஸ் பண்ணும். வாட் இஸ் ஹைப்பர்டோனிக்? ஹைப்பர்டோனிக் வந்து செல் வந்து பர்ஸ்ட் ஆகிட்டு உள்ளே இருக்கிறது எல்லாமே வந்து வெளியில் ஆகிடும். ஸோ that is the reason. So intravenous solution can be prepared from the 0.9% using the only the uses of this using the isotonic of blood cells. Okay, so next one is what is meant by reverse osmosis. Reverse osmosis, what is meant by reverse osmosis? So here that is the process can be reversed by applying pressure greater than the osmotic pressure of the solution side. So what is meant by osmotic pressure? We already studied. What is osmotic pressure? The pressure must be applied to the solution to stop the influence the solvent through the semi-permeable membrane. And the solvent flow வந்து stop பண்ற pressureக்கு பேர் தான் வந்து என்னது osmotic pressure. What is meant by reverse osmosis? அது அப்படியே reverseல வருது. இப்போ என்ன நடக்கிறோம்? So the process can be reversed by applying pressure greater than the osmotic pressure. Pressure greater than the osmotic pressure. Greater than the osmotic pressure. Osmotic pressure to the solution side. To the solution side. Okay. So that is pure water moves from the solution side to the solvent side and the process is called reverse osmosis. Now the pure water moves from the pure water moves from the solution side to the solvents. Solution side to the solvent side. And this process is called the reverse osmosis. So it can be passed through the semi-permeable membrane in the opposite direction of osmosis. So that is the only thing is reverse osmosis. So that is the opposite direction of osmosis when the subject to hydrostatic pressure greater than the osmotic pressure. So here what is meant by osmosis? So here this is only example. This is the semi-permeable membrane. So that is solvent. This is the solution, right? Concentrated solution means solute plus solvent, that is solution. Here that is solvent flow from this lower concentration to the higher concentration, that is called as osmosis. Now the external pressure is applied to that is the fresh water. So now the fresh water reverse osmosis. So இங்க இருந்து நம்ம இது sea water. So இங்க இருந்து அந்த pressure வந்து இங்க திரும்பி வரும்போது இங்க உங்களுக்கு new water வந்து reverse osmosis. External pressure will be greater than applied pressure. So that is called as reverse osmosis. So this reverse osmosis that is used in the desalination of sea water and is also used for the purification of drinking water. So in the RO system, what is meant by RO system? வீட்ல எல்லாரும் வச்சிருப்பீங்க இல்லையா, aquaguard water ன்னு சொல்றோம் இல்லையா. So that is RO system in reverse osmosis. All the drinking water only working under this same condition, reverse osmosis. A simple said to be both the process. So when the pressure higher than the osmotic pressure is applied on the solution side. So this is the solution side. This external excess of pressure will be applied on the solution side. The water molecules move from the solution side up the solvent side through the semi-permeable membrane. So only the pure water, remaining other solvent solution molecules are stay back in this chamber. So remaining will be entered through this. This will be pure water can be collected. There are the different types of semi-permeable membrane used in this process. The reverse osmosis that is with an high pressure. So எப்படி இருக்கணும், so the membrane எப்படி இருக்கும் அப்படின்னா எவ்வளவு pressureலயும் withstand பண்ற மாதிரி இருக்கணும். Generally cellulose acetate or the polyamide membranes are used. So that is the cellulose acetate and polyamide membranes are commonly used in this one. So this is that's all about this lesson. So next one is what is so one more last chapter is there. So next one is abnormal. Okay, abnormal Van der factor, abnormal colligative properties. What is meant by abnormal colligative property? So next we are going to see what is meant by abnormal molar mass. What is meant by abnormal molar mass? Suppose we are calculating the molar mass of the non-volatile solute can be calculated accurately using the experimental method in the qualitative property, any one of the method. Suppose we are using the solute. What is meant by solution? Solute plus solvent equal to solution. Okay, so in any one of the method, so we can calculate the solution. The solution is very diluted, means no problem. So that is no association or dissociation. Dissociation and dissociation period dissociation. Dilute solution, no dissociation, dissociation, no association. The solution is dilute. Solution is dilute, no dissociation, no association. The same thing, the solution is concentrated. Solution is concentrated, highly concentrated. What will happen? So that is the interaction between the solute and the solvent will be more. So that is, it is measured, it is reflected in the measure of the colligative properties. So that is, in this the total number of particles present in the solution hence affect the result in the measured colligative properties. So என்ன abnormal colligative property na என்ன அப்படினா, இப்போ ஒரு solute solvent சேர்ந்து தான் solution அப்படினு சொல்றோம். அப்போ solution வந்து diluted இருக்கும்போது அந்த solute solvent ஒண்ணுக்கு ஒண்ணு mix ஆகி இருக்காது. இதே இது solution வந்து concentrated இருந்துச்சு அப்படினா என்ன ஆகும்? solute solvent ஒண்ணுக்கு ஒண்ணு bind ஆகி dissociation என்னது பிரியிறது, association சேர்றது. So சேர்ந்துட்டு பார்க்கும்போது இந்த colligative properties measure பண்ணிருக்கிற வேல்யூக்கும் concentrated அதிகமா இருக்கும்போது இருக்கிற வேல்யூஸ்க்கும் வந்து different வருது. So that is called as abnormal. That property is determined using the colligative property. What is the difference? Actual molar mass and is the calculated molar mass. Normal molar mass க்கும் so வந்து abnormal molar mass. So that is the and the total changes vary, react பண்ண dissociation association நடக்கும்போது உள்ளதுக்கு vary ஆகிறதுக்கு நம்ம calculate பண்ண போறோம். Example, measured colligative does not dissociate or so இப்போ say for example acetic acid. Acetic acid. So acetic acid, so that is it is combined with benzene to form the dimer. Okay, dimer or trimer. Certain solvent, it is bind with the sum of the molecules to form the dimer or trimer. This is reduces the total number of particles formed in the solution. Calculated molar mass will be higher than the actual molar mass. Say for example 2CH3OH. This is acetic acid. After bind with the benzene, okay, benzene to form the dimer of acetic acid will be formed. So now what is the molecular weight of this acetic acid? The dimer acetic acid is 120 gram mole inverse. Okay, so but the normal actual molar mass of acetic acid is how much? So that is 60 gram mole inverse. The actual molecular weight. Okay, this is the calculated molecular weight. Okay, that is 120 gram. So this is the actual molar mass. So this is the difference. So that is we can be calculated. That is one factor that is introduced, Van Hoff factor. So that is Van Hoff, introduced the Van Hoff factor. Van Hoff factor. What is meant by Van Hoff factor? So the Van Hoff factor, that is association or dissociation, that is observed colligative property and the colligative, that is calculated colligative property. What is meant by alpha? What is I? The term introduced Van Hoff factor is small I. Okay. So what is meant by I? I is equal to, what is I? Normal molar mass. Normal molar mass divided by abnormal molar mass. Or observed colligative properties are the calculated colligative property. The estimated, the acetic acid, that is the benzene. So this is the Van Hoff factor using the following relationship. So that is alpha dissociation. What is the formula of dissociation? Dissociation of period. Okay, that is I minus 1 divided by n minus 1, where n is the number of moles formed by the dissociation of the single molecule. So the same thing, what is meant by association? What is association? 1 minus I n, okay, 1 minus I into n minus 1, number of solutes. So that is These equations relating the 4 qualitative properties of the concentration of the solute can be rewritten. So that is the what is the depression or lowering of vapor pressure, depression of boiling point and the freezing point. How to relating, that is the what is the relative lowering of vapor pressure. Lowering of vapor pressure is equal to, we already calculated, P0 solvent minus P solution divided by P0 solvent equal to I into N solute divided by N solvent. This is the calculation. So the same thing, elevation of boiling point. Elevation of boiling point equal to delta TB is equal to I into KBM. Okay. So depression of freezing point, delta TF is equal to I into freezing constant into molality. What is osmotic pressure? Osmotic pressure is equal to, osmotic pressure pi is equal to I into W solute divided by volume into RT by M solute. So for this solute, we can the associate to form the association dissociation to be calculated. The another one is for the solute dissociate. Suppose the solute to associate higher solution, the Van der factor less than 1 means observed molar mass will be greater than the actual molar mass. Suppose I less than 1, I greater than. What is the condition? So the Van der factor will be more than 1. So that the observed molar mass will be less than the normal. So less than 1 means the observed molar mass will be greater than the actual molar mass. Actual molar mass. Okay, greater than 1 means that is observed molar mass less than the actual molar mass. This is the condition. Sometimes they are asking for 1 mark. I less than 1, that is that is the calculated molar mass greater than the actual molar mass. Calculated molar mass is less than the actual molar mass. This is the what is mean by I is equal to Van der factor. Okay, so that's all about this chapter. So we see the next video, that is the new lesson. Okay, thank you children.